there needs to be a global standard for how the financial market infrastructures of the world, how the central banks of the world interact with each other and with chains. And that is a really kind of long game type of problem. That's like a 5 to 10 year problem. How can we get the world on an efficient, secure, single standard? Like if I look back on my life and I spent 20, 25, 30 years getting the whole world on a single efficient standard across chains, across FMIs, across all banks, across all startups, I know that I'll be able to sit back, look back at that and be proud of that.
Hey everyone, wanted to give a quick shout out to the Wormhole Foundation. If you're a Bell Curve listener, you know that transferring across chains can be a massive pain. I certainly do. I complain about it on this program all the time. That's why we are super pumped to have partnered with the Wormhole Foundation, the stewards of the Wormhole Protocol. The Wormhole Protocol connects over 30 blockchains and 6 different runtimes, including Solana, Sui, Ethereum, Layer 2s, and more. And the coolest part about this particular partnership is that they have made custom Bell Curve NFTs, which you can get and mint for free. You can claim that by just going down into the show notes and clicking on the link. All right, guys, on with the show. Hey everyone, this episode is brought to you by Swell, a team leading the restaking future with their liquid restaking token, RSweep. Now, I've talked about liquid restaking on this program before. I think it is going to be a massive tectonic shift for Ethereum, and I am super excited about it, and I like the Swell team a lot. It goes without saying, do your own research. This is not financial advice. You guys all know the drill. Again, I like this team, and if you stick around, I'm going to describe how you can restake your ETH in Swell, earn pearls, eigenlayer points, and a whole bunch of future rewards. So thank you very much for Swell for making this episode possible. Hey everyone, wanted to give a quick shout out to this episode's sponsor, Flood Protocol, the optimal DEX aggregator. Now, if you are a listener of Bell Curve, you know that MEV is a massive problem, which is why we are so pumped to partner up with Flood on this season. Flood is the only gasless and MEV-free aggregator that not only gets you the best execution, but also gives you back all the extra surplus that you create every single time you swap. Now, this is relevant for both swappers and developers, but you're going to be hearing all about them later in the program. So for now, thank you, Flood, and back to the show.
All right, everyone. Welcome back to another episode of Bell Curve. Before we jump in, quick disclaimer. The views expressed by my co-host today are their personal views, and they do not represent the views of any organization with which the co-hosts are associated with. Nothing in the episode is construed or relied upon as financial, technical, tax, legal, or other advice. You know the deal. Now, let's jump into the episode.
All right, everyone. Welcome back to another episode of Bell Curve. You got Michaels 1 and 2, Vance, and today we've got a very special guest, Sergey Nazarov, the co-founder of Chainlink. Guys, welcome to the show.
Great to be here. Great to see you here, Sergey.
Great to be here. Thank you for having me.
Yeah, this is special. I feel like I'm reuniting sort of old friends here. So I'm gonna do my best to stay out of the way and just facilitate banter between the boys. But Sergey, I've been a fan of Chainlink for a while, so it's really special to get you on the program. We did an interview with Chainlink God a couple months ago, which was really fun. And it's going to be fun also to see you in London in person soon. But maybe to just kick things off, I'd be curious to get your perspective as the co-founder here. How has Chainlink evolved over the years from, I used to think of it as sort of pricey, but now the way that at least I think about it is kind of a platform of data, compute, and cross-chain services. So can you just walk us through what that transition was like?
Yeah, sure. So in making Chainlink with the initial white paper, I would say that the invention of decentralized Oracle networks led to essentially a new computing environment. The computing environment, decentralized Oracle networks, generates consensus about all the things that need to become trust minimized, but that blockchains do not make trust minimized. So blockchains generate consensus by independent nodes coming basically to the same conclusions against the protocol on the question of transactions being packaged into blocks that are then connected to each other to form the blockchain. And so the consensus mechanism there is used for pretty specific things, mainly for transactions in a data structure that are packaged together in a very specific way with some amount of computation on top of them. Oracle networks do not make a chain. There is no Chainlink blockchain. There are no Chainlink chains. Oracle networks use the same consensus approach as blockchains, but instead of generating blocks of transactions, they validate things about the world. The initial thing that Oracle networks were used to create validation for was price data, because price data is a necessary condition, is a necessary input into DeFi applications. And this is why DeFi was sub 100 million when Chainlink was live for the first time, and it grew to over 200 billion, with Chainlink powering something like 50, 60 to 90% of the entire DeFi ecosystem, depending on how you count it, if you discount DEXs. So the first use case of decentralized Oracle networks as a computing environment was price data aggregation. And that is a similar pattern to what you see in other platforms out there in the world. So if you look at the cloud platform history, you'll see that S3, which was the first service made by AWS, was able to prove that the cloud model worked, right? That cloud computation was something that you could seed valuable computations and data storage to. Well, in that case, actually just data storage. And then after S3 proved that cloud could do things, because there was a lot of doubts about that, then you had other services in AWS appear, like EC2 and others. Similarly with Salesforce, the first killer application they made was a CRM, but then they made many others. And you can even take it to a consumer level of spreadsheets were the first killer application of personal computing. So every platform kind of begins really with a new computational model, a new way to do computation, and then it successfully applies that new model of computation to something very specific that is also very in demand. And that is the starting point of that platform, both in terms of having a market for the platform to do something and in terms of proving that the system can do something more. So for example, Chainlink has now processed over 10 trillion in transaction value. And in processing that much value, it has proven that the decentralized Oracle network model can secure trillions of dollars in transaction value. The next question with all of these kind of platforms that are based on a new type of computation is usually, what else can it do, right? So to answer the question of what else can it do, then Chainlink went on to add proof of reserves to the protocol, and Chainlink is the largest provider of market data, reference data, and proof of reserves. Then it went on to provide access to other types of data, identity data, weather data, and others. It's the largest provider of those data sets as well. Then we kind of asked the question, can Oracle networks do computations that are valuable without connection to a data source? And that's where VRF, the random number generator, automation and functions came out of. VRF, the random number generator, from what I can tell right now, is the single most widely adopted source of random numbers in the blockchain industry across blockchain gaming, as a single source that the most different blockchain game systems use, other than some kind of homemade thing, which people generally don't trust for various kind of centralization reasons. The automation solution secures some of the highest value contracts out there. Functions is a more advanced form of computation. And the cross-chain system, CCIP, is using the same decentralized Oracle network model and security to provide cross-chain connection. Across all of these things, by the way, whether it's data aggregation, computation, or cross-chain connectivity, you really have the same fundamental problem of validating commands, computations, or data. And that's what Oracle networks do. So I think the thing that people really need to understand about Oracle networks is that they are a computation environment, right? They are a type of way to do validating computations on really anything, including interacting with AI models, interacting with other chains. The most general way to think about Chainlink would be anything into chains, out of chains, or between chains is what Chainlink will basically have a very big role to play in. And then there's also another level of this where the validation that the Chainlink networks create, I think, will also, and I've started to see now, are also valuable for Web 2 systems, because those systems will also prefer to have a more reliable source of data, a more reliable source of computation, a more reliable connection. But all of that, once again, assumes that that's not what the blockchain does. So Chainlink creates all of this consensus, decentralization, security, validation about everything and anything outside of a chain. And the chain continues to act as the kind of data resource, smart contract code resource, transaction execution resource. And that's, a great thing because they're very good at that. And Oracle networks are very good at validating everything else.
So Just to kind of play this back a little bit, in 2019, I think is when you guys announced some of the first partnerships for the price Oracle solutions for DeFi. And maybe the dates are slightly off, but 2020, 2021 were VRF and these functions capabilities. And now, CCIP, the Cross-Chain Communications Protocol is sort of the place where you guys are moving towards. And I think one of the things to note about Chainlink writ large is you guys have been ahead of the curve in terms of, what is going to be the computational need for these different types of application categories. You were about a year ahead of DeFi summer with price feeds and enabling so much of what happened within DeFi in 2020. And obviously the games ecosystem and the functions capabilities are, what's powering many of the games that exist today. CCIP is, kind of the next leg up in terms of complexity, but also where you guys are moving in terms of where you're focusing your resources. Maybe it would be helpful just to talk about some of the applications that CCIP and kind of the cross-chain communications protocol that you guys are building are going to rely on. And maybe after that, we can talk more about how the protocol actually works, because I think it'd just be helpful to better understand, what we're talking about with CCIP.
Yeah, sure. Of course. So because the Chainlink system has been building these other parts of what Oracle networks do, such as the data part and the compute part, the cross-chain part is built with those portions of the protocol in mind. So other people that build cross-chain protocols generally make a protocol that we don't consider to be smart. We consider it to be like a dumb, simplistic protocol that will just do anything people ask it to do, and it won't consider the risks, and it won't consider the security issues, and it'll just power through and send $600 million without any verification of if it should do that, right? So this is where a lot of the cross-chain hacks happen from. So the first thing about how CCIP is built is that it's really both a data transfer protocol and the token and value transfer protocol. It's both of those things at the same time. There are people that have built value transfer protocols. There are people that have been trying to build data transfer protocols, but there aren't many people building data and value transfer. And the reason why providing a protocol that does data and value transfer is you can actually connect data to value in very powerful ways. So, for example, in CCIP, we have a feature called programmable token transfers, PTT. And what PTT does is it allows you to send a token, a stablecoin, for example, to another chain with a set of instructions for what that token will do on that chain. So it allows the token to reach the destination chain, to trigger a specific contract and a specific function in that contract, and to basically execute the outcome that sending the value there was meant to execute. And this is because data and value can be connected in a single system. Now, this is actually a very powerful thing because the way that most bridges work today is you take value out of your wallet, you put the value into the bridge application, you bridge it across, you take the value out of the bridge application, then you put it into your new wallet, which you were forced to generate in some new place, and only then can you use the desired capability of the application of the exchange or the lending protocol or whatever you wanted to do on that chain. CCIP compresses all of that down into a single, basically event, a single kind of transaction and problem for the developer, where they can basically define, I want to go to blockchain X, I want to go to smart contract Y, and I want to execute function Z. And they can do that because the data as a set of instructions and the value can all move together. The second thing that CCIP does is something called risk management. So the way that all value moves across the current internet is that there are various methods for managing risk, for determining how risky transactions are and at what speed they should move and how much should be moved and so on. And this is the basis of moving value across the world today. This is not something that, amazingly enough, exists in other bridges. And this is why they have a lot of bridge hacks. And this is why a lot of transactions that happen that people didn't want to happen actually end up happening. So CCIP has a configurable part of the system called the risk management network, where you can essentially encode various policies that determine how value can move. And this will actually be the crux of how value will move over CCIP between the traditional financial system, TradFi, all the big banks, all the big asset managers, and DeFi. And I personally think that this is one of the main goals of a successful cross-chain system. There's kind of the ability to make Web3 transactions happen across public chains. There's the ability to make private chain transactions happen across private bank chains. And then there's the ability to merge all of those chains into a single internet of contracts. So that's really the fundamental goal of CCIP. And then, by the way, all of those transactions across all of those chains will require various pieces of data in order to happen. So they will, for example, require price data to do settlement. They will require identity data to be able to be accepted by a counterparty. They will require proof of reserves in order for someone to be assured that what they're receiving is actually backed by something. So the way that CCIP has been built is to actually interface efficiently with all the other parts of the Chainlink system in an increasingly efficient way. Like it's moderately efficient now, it's going to become more and more efficient, where not only can CCIP allow you to move value and data, but it can actually allow you to stay informed about what's happening with the asset as it moves across different chains, because the data can flow through CCIP across those chains and back. So as a cross-chain protocol, it's not just meant to solve a single problem of, I just want to move a token to another wallet, and then that's someone else's problem. The point here is to make the cross-chain process secure, efficient, and able to transmit data along with value. And so those three goals are really why it's taken, I think over 3 years now to make CCIP. And the security, I think, is actually one of the main reasons it'll continue to win. It's because it's the same thing that led Chainlink to be widely adopted in the data space. There were other ways to do Oracle price data delivery. They simply weren't secure, and people continued to be hacked. And when we look at the security of other bridges, we see a lot of faulty assumptions that I think will lead to the loss of value and real security issues that CCIP doesn't have. So our goal is to have a system that provides security as the value going through the system grows. And that's really, I think, the thing that has made Chainlink the standard it is today, and what will continue to make it the standard for years to come.
So just to ask a little bit more about that. So it sounds like, you could have these private chains that have basically like security configurations established by CCIP in terms of what value transfer can happen, what messages can be passed, etc. Like, is that kind of the fundamental value prop for a lot of the kind of tokenization plays that the large institutions are looking at? Or like, what are the other reasons why they use this versus anything else?
That's one of the pieces of value. I think what you see when people in the Web3 infrastructure space build things is they build technology that is sometimes shipped quickly and not securely. Then there are some people that actually care about security, but they focus on one set of requirements, namely the Web3 requirements. So CCIP is built across two sets of requirements. It's built across the Web3 requirements and the capital markets requirements. And the reason it's built across both sets of requirements is because the capital markets are where the money is. Like DeFi applications and protocols don't really care where the money comes from. Money is just money. It doesn't matter if it comes from an anonymous wallet address or if it comes from a Goldman Sachs blockchain address. Fundamentally, all DeFi protocols will simply want the most TVL, the most usership, the most adoption. That's just how economics and the creation of application works, right? And so at the end of the day, you'll arrive at a world where everyone will realize the very basic arithmetic that while there is another few $1 trillion in the non-TradFi, non-capital markets economy, there is literally tens to hundreds of trillions of dollars in the TradFi economy that needs to get bridged in. So to answer your question more specifically, yes, the ability to set various policies about how a private bank chain interacts with another private bank chain, and how that private bank chain interacts with a public chain DeFi contract, for example, and to set those conditions in ways that allows the bank to do that at all, instead of ignoring those conditions, is definitely an important requirement that needs to be met for the banks to do that. Because my fundamental goal is to make the blockchain industry and the blockchain smart contract Oracle network powered format the format for all value, right? How does all value get originated, managed, and transacted in a blockchain based Oracle network powered way? That's the fundamental goal. And you're just not going to achieve that goal unless you create an efficient path for all of the world's value to flow into that format. And there is a part of the world where that value doesn't need certain features, doesn't need to meet certain requirements. And that's great. And that allows that part of the world to move very quickly and do innovative, exciting things. And that's a great thing. And I'm a big, big believer in that and a huge supporter of it. And we've been supporting DeFi and Ethereum and all these great things as much as we can. But there's just a simple reality that there's all this other value in these other systems. And the key thing is, one of the key questions is, how does all of that value transition? And that transition is the big transition. That is it. That is what we're all fundamentally kind of trying to work towards here. And so, yeah, to answer your question, that is one of the features. The other features that people like are the security guarantees. So, for example, we've been working with Swift since 2016, and Swift powers quadrillions of dollars in transaction value. And we have our second public thing with them. But there's been extensive security review of how our system works versus other systems. And there's just a certain higher level of security that you need to meet for institutions that have been moving around value for 50 years, because they've been trying to be hacked for 50 years rather than 5 months. And so they have all these really, really high security requirements. So I would say there's the risk management requirements, the security requirements. For example, CCIP, I think now has gone over 10 audits successfully and continues to be audited as anything is added. So I would say those are two important things. And then the other thing is, we already have a good amount of people that people want to transact, of counterparties that people want to transact across in the capital markets getting on CCIP. So our goal here is to create an internet of contracts in Web3 powered by a data standard and a compute standard that allows people to transact reliably. And to do that also in capital markets with a slightly different set of requirements, maybe 20% different set of requirements, often around identity or something else. And then to merge those two internet of contracts powered by a shared set of data standards, compute standards, and cross-chain connectivity standards into a single internet of contracts that like the bank can use a DeFi protocol because they know it's secure, because it's powered by Chainlink data and it's automated through Chainlink automation, and they connect to it through Chainlink CCIP. And that meets their security requirements, and therefore they can use that DeFi protocol. And the DeFi protocol can, rely on the bank system because of the connectivity guarantees and other similar guarantees of Chainlink that are present there. Because you need these guarantees in order for people to be able to transact. People need to arrive at a shared agreed on standard for price. People need to agree on a shared connectivity method in order to transact. And so those standards, those shared guarantees is what Chainlink is providing more and more.
What else are you guys doing beyond tokenization in the capital markets? Like, you alluded to a little bit of like other use cases or things that you might be kind of doing, but would love to hear more about what Chainlink's doing beyond tokenization.
Yeah, so I'm not sure how detailed I can go into things here because of some of the discussions we're having, but I'll give you more of a historical context. So if you look at how the global financial infrastructure of the world has evolved, you'll eventually you'll reach something called the paper crisis in the 70s. And the paper crisis in the 70s is what led to the digitization of the global financial system. Because basically there was so much paper moving around that you couldn't finalize transactions because of the volume of paper things that had to be sorted through at any one time, basically. And that created various bottlenecks and market risks and various other issues, basically. So there is a dimension of how the financial markets will evolve based on what banks want to do and what asset managers want to buy and what hedge funds want to buy and what asset issuers want to do. And that's the market dimension. That's how does the market function? What real world assets does the market request? What real world assets do asset managers want to hold on their books for their clients? What real world assets do asset issuers want to create? That is the market dynamic that will essentially pull various implementations out of the technology and push into the market, right? Then you also have the global financial systems FMI community, the financial market infrastructure community, which are the people that run the infrastructures that power the current financial system. And there are questions there about how does the financial market infrastructure community work with these new blockchain challenges? How do they provide the value that they provide? How do they provide legal guarantees, identity guarantees, whatever guarantees, which, by the way, is a hard requirement for those banks to bring their trillions of dollars into the system. So we are also working through solving that problem. So we are working through solving how do we get use cases off the ground? How do we tokenize private equity? How do we tokenize real estate? How do we tokenize carbon credits? How do we tokenize more gold? How do we tokenize, whatever, frankly, the asset issuer or the asset purchaser, the counterparties want to tokenize? And there's double digits of conversations now with top institutions where that is relatively far along. Then you have questions of how does doing that comply with the kind of requirements that they have to comply with in order to make that asset? How does all of that interaction happen in a way that they can be legally comfortable with it happening? And there you also have to do various data connections, connectivity around various, what's called the CSD, a central security depository. There's one in each country, actually. And so there's this other infrastructure level that we are also working together with various infrastructure providers on to help them essentially provide value to that transaction and allow it to continue in a legally compliant way that allows it to happen. And if that doesn't happen, then all the value from the banking system doesn't go. It just doesn't come in. And if that does happen, then the value does come in. And then we're not talking about, 1 trillion or 2 trillion or 3 trillion on blockchains. Then we're talking about tens of trillions to hundreds of trillions on blockchains. And once again, that's the goal that at least I have set in my mind for what it is that I'm trying to achieve here, right? What I'm trying to achieve is that in 2, 3, 4, 5, 10 plus years, all of the world's value across derivatives, equities, commodities, real estate, gold, ad networks, global trade, gaming is in a blockchain format. It's interoperable across multiple chains. It's able to be understood and transacted around because people understand the data needed and they have data standards in order to do those transactions. And it's all being kind of managed and transacted on blockchain infrastructure with a shared set of data, off-chain compute, and connectivity standards.
So maybe like a philosophical perspective that I think you're trying to describe, maybe a summation of that is sort of you're trying to provide that public-private partnership where the public blockchain is now able to be connected to the private institutions, and you're facilitating some of the connection and connectivity and requirements, et cetera, that are required by those private institutions to be able to bring that value on chain. I'm just curious, like when you guys are thinking about new product development, moving from price feeds to functions to CCIP and connectivity and value and data transfer, how are you thinking about it when it comes to, are you building the infrastructure first and then kind of showcasing what the proof of concepts are, what the applications could be? Is this more kind of demand led where you're having the institutions come and say, hey, we want to bring this stuff on chain. How do we do this? Like you guys have been forward thinking in just about everything that you've done so far and ahead of the curve. I'm just curious, like, how do you ideate and think about, how to continue to be ahead of the curve and, in relation to the institutions and partners that you have?
Yeah, sure. So there's three kind of worlds here. The first world is the Web3 application developer world where you have, great teams like Aave, GMX, DEDX, and others, right? You have these great teams that are building these cutting edge things, and we're working with all those teams, and we're trying to listen very closely to what it is that they're trying to do in their application, and then we and the larger Chainlink community is trying to implement that in some technical way into this public open source shared global protocol that they're all using, right? And that is a process that happens through conversations, through DAOs, through a number of different channels. Those features that get made in the Web3 world are 80% transferable to the capital markets. The large benefit that we have is that in making all of those features and making them securely, we are able to prove that they work for real value in production. And by working for real value in production, that puts us significantly farther ahead of a lot of the enterprise blockchain companies, which don't deal with production. They don't deal with a live system. They deal with an idea that they want to make a live system, but it's going to take them 3 to 4 years to get through the process with their counterparty, with the enterprise client. So we already have systems that work on production, solve 80% of the problem on production, live, trillions of dollars of transaction value through the system, highly secure for many years, and has the features developers need, right? So that's great. So that we have through a very rapid customer development iterative process with the Chainlink community, the great teams that we're very lucky to work with. And what we focus on there is security. And that sometimes creates friction points where people want to do something that isn't a secure way of doing it or isn't a secure feature, and that creates certain amounts of delays in releasing things. But once again, the goal here is not to release features that everyone wants whenever they want them. The goal is to release features that there are good assurances are secure and secure enough to handle the purpose and the value that they're meant for. And that is the thing that I think will float any infrastructure over time. That is the thing that has floated AWS, Swift, all these systems over time, is that they are secure over time, right? So that's how we deal with the Web3 community, rapid customer development with a focus on making sure things are secure. And that sometimes does create friction and does create delays, but it's net better for everybody because the system is secure and their application ends up being secure. Sometimes people go and do things without us that are not secure. Oftentimes they find they're not secure and come back, right? That's the most common experience we frankly have. And their logic for doing that was, oh, you're taking too long or something costs too much. And we're like, okay, that's totally fine. Go do something else. And then if you have a problem, you can come back. And we have pretty good reasons to believe we know why they'll have certain kind of problems. So great. Highly iterative development would focus on security. Then you get to the second group. The second group is the capital markets, the world's largest asset managers, the world's largest banks, the world's largest hedge funds, the world's largest sovereign wealth funds that all want to have real world assets, want to generate real world assets, want to do tokenized private equity, tokenized carbon credits, tokenized real estate, tokenized whatever, tokenized money markets, tokenized treasuries. They have an additional 20% of requirements, and they generally move slower. The big thing that has changed there is that they now have dedicated digital asset teams. So what I did not see a year ago for most people is a dedicated digital asset team. I did not see dedicated engineers with a digital asset engineer title, dedicated digital asset product manager, dedicated digital asset product marketing, digital asset this, digital asset that. I did not see that 1 year ago in most places, and I saw it only really start happening 2 years ago in a few small places. And so these folks now have dedicated team members, dedicated budgets, dedicated plans, dedicated goals, dedicated things they have to do, like they have to launch a token and do a transaction. So with them, we get their requirements. We layer that into the already 80% we have working on live on production. And that's really where I think there's this big advantage, right? Where we can make systems on production, but we also understand capital markets requirements because our goal is not to kill everybody. Our goal is to make everyone work together, right? My goal is not to kill this group or that group. My goal is to get everyone to work together. And if somebody doesn't provide value to the system, then they naturally won't be in the system. Like, it is not my job to remove them from the system. My job is to create a very flexible system together with a large community that can allow anyone who can provide value to participate in transactions. That value can be identity-related value, market data-related value, whatever other value, right? Connectivity-related value as a node operator. So this second group provides you the requirements to do capital markets things. Then there's a third group, and the third group is the financial market infrastructure world. That's where people like Swift live. That's where CSDs live. That's where certain identity providers live. This is kind of the financial market infrastructure world that processes quadrillions of dollars in transactions every year. And this world also has a certain role to play in how they will interact with all of these on-chain transactions. And there needs to be a system to facilitate that interaction. There needs to be a way how CSDs interact with blockchain transactions. There needs to be a way for identity solutions to interact with blockchain transactions. There needs to be a way for central banks to interact with blockchain transactions. All of these systems are going to continue to exist, and they need some technology. They need some way to interact with this more and more fragmented, more and more value securing blockchain ecosystem of various chain technologies. that by the way also need a data standard in order to transact. So that third group is the slowest moving group because, and I didn't understand why they were slow moving until a few years ago. But after being part of building a system that secures this much value, I actually do understand. When you secure huge amounts of value, you really have to understand what you're doing before you do it, because it's a different set of responsibilities versus I'm a startup with 3 people and I'm just going to throw something against the wall and see if it sticks, and if it doesn't stick, I'm back to where I was 10 minutes ago, right? So you have to come up with ways to continue to provide security while creating new features. That's what these people in the financial market infrastructure community are trying to do. These are the people you see us interacting with when we go to like Sibos and when we go to these other conferences. And there needs to be a global standard for how the financial market infrastructures of the world, how the central banks of the world interact with each other and with chains. And that is a really kind of long game type of problem. That's like a 5 to 10 year problem. But I've already been doing this for well over 10 years, and I like it, and I'm totally into doing it for as long as it takes to get the whole world on a single standard. That's the thing that's actually very exciting to me personally, is how can we get the world on an efficient, secure, single standard? Like if I look back on my life and I spent 20, 25, 30 years getting the whole world on a single efficient standard across chains, across FMIs, across all banks, across all startups, I know that I'll be able to sit back, look back at that and be proud of that. So there's this other group that people really don't understand, which is like the total long game of blockchain infrastructure and financial markets infrastructure.
Sergey's not going anywhere. You've been living in the future for a while. I like it.
Hey everyone, wanted to give a quick shout out to the Wormhole Foundation. If you're a Bell Curve listener, you know that transferring across chains can be a massive pain. I certainly do. I complain about it on this program all the time. That's why we are super pumped to have partnered with the Wormhole Foundation, the stewards of the Wormhole Protocol. The Wormhole Protocol connects over 30 blockchains and 6 different runtimes, including Solana, Sui, Ethereum, Layer 2s, and more. And the coolest part about this particular partnership is that they have made custom Bell Curve NFTs, which you can get and mint for free. You can claim that by just going down into the show notes and clicking on the link. All right, guys, on with the show. Hey, everyone. This episode is brought to you by Swell, a liquid restaking protocol and the issuer of the RSWEETH liquid restaking token. Now, if you're a listener of Bell Curve, you know that I am just so fascinated by restaking and liquid restaking. I think it is going to be one of the most important trends in Ethereum, and I am really excited for the benefit that it unlocks both users and also Ethereum, the protocol itself. Now, disclaimer, whenever there's yield involved in a product, do your own research. This is not financial advice. You guys know the drill, but Swell is a great team. They have a non-custodial product, and they are mission-driven on giving you the best liquid staking experience. If you take one benefit away from using liquid restaking, make it be capital efficiency. Now you can earn passive yield from Ethereum. You can earn yield from multiple actively validated services that stack on top of that. And then you can still use RSWEETH as collateral in DeFi. And because I know y'all are a bunch of degens, there's a points angle here as well. But in Swell, we call them pearls. So pearls equal points. And if you stake your ETH with Swell, you can earn pearls and future eigenlayer rewards. And when there's a token generation event, you can swap your pearls for Swell tokens. Head over, click the link at the bottom of this episode. Again, just pause what you're doing right now. Go click the link at the bottom of this episode. Check out Swell. Thank me later. Hey everyone, wanted to give a quick shout out to this episode's sponsor, Flood Protocol, the optimal DEX aggregator. Now, Flood is the perfect partner for this episode on the multi-chain future because Flood is solving so many of the issues that we're going to be talking about this season. And this is relevant for both traders and devs. So if you are a trader, you should definitely head over to Flood Swap and start trading because they solve 3 massive problems. 1, gasless trading. No more pesky trading fees. 2, you don't have to worry about getting front run. MEV free. And then 3, they have excellent order routing so that you know that you are getting the best price. So head over to Flood Swap and click the link in the bottom of the show notes. We're going to send you right there. For the devs out there, you can leverage Flood's flexible hooks, allowing you to make swapping a first-class primitive by adding custom order types like TWAPs. Or if you're a wallet builder or something like that, you can actually build your own order flow auction in and start recapturing a bunch of that MEV. If you want to reach out to them, go to devs@flood.bid or just jump right in the Discord. All right, guys, thanks very much. Appreciate you, Flood.
I'm just curious, like, kind of touched on it, and I think you know the answer. We've seen so many of these enterprise blockchain, like the JP Morgan chain type institutional products come out. Do you think there's any room for that in this world that you're describing?
Yeah, absolutely. I think there's a ton of room in this world.
Or what role would that play in kind of this description?
You'll see basically what I call securitization 2.0. So securitization 1.0 was the thing that led to the market boom up until the global financial crisis. And securitization 2.0 is tokenization. So securitization 2.0 is the not nice way to say it. And tokenization is the nice way to say it, because while tokenization actually provides you security guarantees and transparency guarantees that securitization 1.0 didn't provide. So it's actually a good way to describe it. But I think what's going to happen with all these bank chains is they're all going to have their own stable coin. They're all going to put all of their clients on their own chain with their own address for each client. They're all going to make their own real-world assets about whatever they're good at doing. I mean, think about what a bank is, an investment bank. An investment bank packages stuff into a financial product. That's what this is about. That's all we're really doing here. We're just packaging the financial product into a token thing on a blockchain rather than into a digital thing on a web system or a paper thing on a piece of paper, which is what they did before. Banks are financial product packaging machines. That is what they are. And they are A, constantly looking for more assets to package, and B, they are constantly looking how to package them, and C, they are constantly looking how to move those assets to counterparties that want to buy them so that everyone can make a ton of money doing that. And so all of these banks will have multiple chains for multiple verticals, multiple geographies, where they will tokenize pretty much everything. And then they will have stable coins. And when a JP Morgan client wants to buy Goldman Sachs carbon credit, they will use the JP Morgan stable coin to buy the Goldman Sachs carbon credit. But they will need to know that the Goldman Sachs carbon credit has proof of carbon credit, proof of reserves. They will need to do a mark-to-market operation. They will need to settle against a certain price. So they'll need price data injected into that. They will need identity attached to that carbon credit through some kind of identity data source, putting that in. All of those things Chainlink will do. And then they will need the what's called the DVP. They will need delivery versus payment transaction. They will need to send the stable coin over to Goldman Sachs chain, and they will need to receive back the carbon credit through a protocol. And through CCIP, they will be able to take the stable coin, wrap it in an instruction that says, go to Goldman Sachs chain, go to carbon credit smart contract, and execute the buy function. And then return back to me what was given to you from that buy function, which in this case is the carbon credit. And this is something we've already publicly done with someone called ANZ Bank. This is one of the two largest banks in Australia with $1 trillion in assets under management. So we have a user that we have publicly done something with, that one user, one single entity has $1 trillion in assets under management. That's one user. And there's over 10,000 of these banks or these people. They're not all at that size, but that is what will happen. Everyone will have multiple chains as a bank. They will all have multiple assets. They will all have stable coins. They will all need to transact. They will need data to transact. They will need computation that is off-chain to help the transaction move along. And they will need a connectivity standard that all the counterparties agree are how they connect. And then they will also want to use public chains. And we will all want them to use public chains. And public chains will be kind of the hotbed of innovation. Public chains will be where the consistently highest risk, highest return yielding, coolest new stuff comes out of, that eventually gets repackaged in some bank form. But the DeFi community will continue to be the place that generates the most cutting edge financial products. And the banks will want to access those products for their clients. And so everything that I'm saying is hugely beneficial to the capital markets, because frankly, it'll work much better than it does now, because you won't be able to hide data and you won't be able to manipulate transactions to create problems for people in the traditional system if you put it on this model of functioning. And it'll be a massive benefit to the blockchain world, because this is This is the net new buyers. The whole blockchain industry is driven by net new buyers. People understand that as being the Bitcoin ETF and the Ethereum ETF are going to bring a bunch of net new buyers. You know what's really going to bring a bunch of net new buyers? When every net new buyer can just directly interface with all the public smart contracts without having to deal with ETFs or anything. Like when everybody can just use every smart contract efficiently and securely and in a compliant way that works for them and their legal requirements.
Yep, that's exactly the public chain, private chain relationship that I was talking about with that unified, interoperability layer and standard in between. I love it. I love the vision.
I was curious, Sergey, just about anything that you could say about the security model or the Chainlink approach to security when it comes to decentralized Oracle networks. I feel like one of the things that, I'd love to hear that your guys' value is just security, moving slow, all of that stuff. That sort of aligns with how I think the protocols that ultimately are going to win in DeFi. That's what they're optimizing for. But around things like oracles or bridges or whatever, there have been security concerns in the past. Like any details you can say about the underlying sort of security assumptions or Chainlink's approach, I think that'd be really helpful to understand.
Sure. So this is just another dimension of maybe understanding what Chainlink does. So there's like basically three ways to make an decentralized Oracle network thing work. One way is you could make a server or a bunch of servers that you control. You can control those servers privately, and you could say you've made an Oracle or an Oracle network. That is not an Oracle network. That's just one person controlling either one server or one key controlling 10, 20 servers. This is what a lot of bridge hacks look like, frankly, is it looked like there were multiple nodes, but there weren't multiple nodes. There was actually one key controlling all the nodes, or there was one operator for all the nodes, and there was just one set of nodes. It was just one node, basically, spread out across something controlled by one key. This is like multi-chain was shut down by one key. A whole bunch of other stuff was shut down. A bunch of native chain bridge hacks get hacked because somebody gets access to a single key. And when you go to their website, it's like up and down. Decentralization is the key to our lives, and we love it, and it loves us, and we're going to do it. And then when you actually look at how the system works, it's like, yeah, I just have the one key here on my laptop, and that's the thing that can make the system stop. So that's the first thing, right? That's the first way that a lot of people make a lot of oracles, whether they're for data or identity or for whatever. And just to be clear, there is nobody who has made as many Oracle networks or oracles as us. We've never made oracles that way. And generally speaking, nobody makes oracles about all these topics like Chainlink does, right? Which we'll actually get to a later version of the answer to your question. The second way to do this, the second way to make an oracle and Oracle network is to make an oracle and an Oracle network that does one thing. It just does one thing. It's very good at bridging from specific chain A to specific chain B. Or it's very good at providing one specific piece of data, and we just have a protocol that's just very good for that one thing, just does that. Or not even very good, it just knows how to do that. And there you might actually have multiple nodes trying to do something. And then there's a lot of other problems there where people can manipulate the data and do other things. And to my amazement, some of the business models of some of these places is actually to manipulate the data in order to steal money from the users as their revenue model, which is absolutely, kind of fantastical a little bit, but that's a whole other conversation. So basically, the second model is I make one oracle on one specific topic. The third model is what Chainlink does. Chainlink is a system for making oracle networks about anything you want, basically. And it has core security assumptions, core security properties, core security guarantees that you can then reuse for bridges, for data, for computation. And this is actually why CCIP, every CCIP bridge and lane, is actually 3 oracle networks working together. So most other bridges are basically either one oracle network or one network sending all the transactions through one place, which doesn't really scale. Or it's 1 or 2 nodes trying to do transactions in a minimally secure way. CCIP is actually over 20 nodes across 3 networks. 3 separate oracle networks are all checking things. And they're all checking specific things. This is what we call the fifth level of cross-chain security, when you actually have multiple networks checking things. And the reason that Chainlink can do this is because Chainlink is a framework and a system for making multiple networks work together. So there's a committing Don. Don is a decentralized Oracle network. There's an executing Don. And then there's the risk management Don. The committing and executing Don basically verify that transactions are functioning correctly. And the risk management Don is where you put all those conditions we talked about earlier. That's where you can introduce things like rate limits or other security, key security guarantees. So the way that the Chainlink system is really being architected is that you can compose an Oracle network with the degree of security that you want. And now, for cross-chain bridging, you can actually combine Oracle networks to create greater degrees of security. So the whole point of the Chainlink system is not for us to tell you how to build a Chainlink Oracle network. It's for the system to allow you to add whatever nodes you want. If you want a bunch of telecommunication company nodes, you can have those. If you want a bunch of Web3 nodes, you can have those. If you want to combine them, you can have that. And you can naturally yourself scale up the amount of nodes that you want. And then you can modify even how multiple networks work with each other. Like, for example, you can actually add a fourth network to the CCIP process, right? You could say that I don't want to accept a proof of reserve backed token unless I verify that the proof of reserve's proof about that token is valid. I don't want to accept tokens that don't have solid proof of reserves guarantees into my chain. And so now you have the three core CCIP networks, but then you can have a fourth proof of reserve network that's proving something to the risk management network. You see? And another way to think about it is that Oracle networks are really decentralized microservices. And Chainlink is a way to generate thousands, hundreds of thousands, and eventually millions of these decentralized microservices to solve all the security and transactional problems. Like, you could even do things like, one of the things we've discussed publicly now, so I can mention it, is Oracle networks as an interface to AI models. And the AI models can be used to check various things for you before a transaction continues or before a transaction goes ahead or even do the transaction for you. So things like that, which could be another kind of Oracle network you add into the mix. But that's really the model of Chainlink is scaling the security of any one network and now having the ability to connect the networks into more and more advanced combinations that are then finally connected to a smart contract, which is the transactional mechanism itself. And then that transaction is very feature rich. That transaction has all the data it needs, has all the connectivity it needs, has access to AI, has access to whatever it needs in order to function as an advanced, secure, basically more robust, more feature rich transaction. That's, I guess, another way to look at it.
How does a risk management Dawn work?
Sure. So the risk management network basically has some hard conditions encoded into it, and then you can add other conditions. And the conditions are pretty much configurable. And they're configurable by the asset issuer, the chain creator, all these other folks. If you look at how value is moved across non-chain systems, you'll see that they all have risk analysis teams. They have all these folks that are constantly considering how risk works. And this is actually the history of moving value across all of the Web2 systems in the world. It's evaluating how risk works. It's not just moving everything. It's evaluating risk and connecting that evaluation to various data sources, systems that evaluate risk properly. And the relationship between risk is a direct relationship also between speed and cost. So this is the other fundamental truth of moving across all value, is that if you don't create a fundamental relationship between risk and speed and cost, you're basically shifting the cost to someone else. And that's the fundamental thing that I think people making a lot of these bridge things are not necessarily getting. They're creating security risks and they're creating various costs that are not maybe even clear to them, definitely are not made clear to the users of the systems, and only become clear when the costs and the risks fall down, which once again, in line with our goals, is not the goal. Our goal is to meet a standard where hundreds of trillions of dollars can be transacted over a globally distributed set of different chains, probably millions of different smart contracts, and then all of the value moving between those contracts and those chains, and all of the data that is necessary for all of that value to be transacted is properly secured. And that's actually a necessary condition for that. If you do not have a mechanism that manages risk in connectivity, if you do not have a mechanism that provides reliable data for settlement that everyone can agree is a good resource for data, for reliable settlement, not just settlement because, whatever, but like I can reliably settle transactions. That is a hard requirement for all of this to go to a new level. So we are trying to build things for that level of requirement so that the system could handle that level of usage.
Along those lines, I'm curious, for our space to be able to, get to the point of the adoption that you're talking about, trillions of dollars from traditional institutions coming on board, are there any things that you guys are looking at and saying, okay, we need this or that, or this development, we need this capability? Are there any missing Lego pieces that you're waiting on, or is it really just kind of a time, equation right now, and it takes time to develop these products and services and time for market adoption? I guess I'm curious if there's any missing components that you guys see right now that we need.
The capital markets is like this big layer cake of a bunch of systems all working together. And the only real hindrance or delay that we have is the decision-making of different parts of that layer cake, of the different parts of that kind of onion, of different steps in the transaction, aligning on a way to do those transactions, basically. That's our biggest limitation there. I mean, we've been working with Swift since 2016. We've been working with a lot of other big institutions. We've been in discussions and working together with various market infrastructures for many years now. Much of that is not public. Basically, by way of educating them, working with them, coming up with shared plans. It's a multi-year process to get a large group of participants, each of which have thousands to tens of thousands of people, aligned with a single set of global standards. But that is the biggest hindrance. That they will admit to you also that is always their biggest hindrance, because there's just so much value and so many people and so many interests that need to get aligned. But we're very lucky to be having good collaborative relationships and good working dynamics with a lot of the people that tend to solve that problem, like Swift, for example, are the people that set global financial market standards. We work with others that set global financial market standards. And in working with them, we can definitely see how you couldn't really do this without them, right? You need them to set a set of standards that the global financial system kind of works along. And it's a challenging process. And they admit that it's challenging, and all the participants, it's just there's so much value and so much money. That's the biggest hurdle. Whatever they want us to build in terms of identity connectivity, in terms of cross-chain connectivity, in terms of data connectivity, we've generally never had a problem with that. There's never been any problem or limitation there. They generally don't like to speedily ship things, so they're more cautious on security even than us sometimes. So they're extremely cautious people, because it's been hammered into them that, they're responsible for people's life savings and all this type of stuff. And it's like they take it extremely seriously. There's all these laws they have to worry about. The Web3 people are also great, and we try to ship everything as fast as we can for them, just to be super, super duper clear. I really see it as we have helped set some global standards that make transactions happen smoothly in DeFi. There are other people that for the past 50, 70 years have been setting similar transactional standards in the capital markets. And what we're trying to do is work with the Web3 community and the global financial system community to come up with a single set of shared standards that allows transactions on the data level, on the off-chain computation level, and on the cross-chain connectivity level to happen. The blockchain decision, the choice of what chain to use, we commonly talk to people about EVM. We describe those technologies. We describe other technologies, but basically that is their decision. We do not have a particularly large role to play in what blockchain technology they will choose, frankly, because it's just something they've already been doing, right? They've already been in a sales cycle with some enterprise blockchain provider. Our main goal is to create a single set of transactional standards on the dimension of data, off-chain computation that's required for the transaction to happen, and cross-chain connectivity that's required for the transaction to happen. And that is, I think, going to be hugely beneficial to both the traditional society and the Web3 society. And eventually going to merge those two places into one global, we call it Internet of Contracts, which is I guess I would say that's our medium-term goal, is to start having more and more transactions between Web3 teams and contracts and capital markets chains, and then as quickly as we can get those transactions across those two worlds to start happening. And I think that's going to start happening, sooner than some people expect, because the laws are starting to become clearer in certain parts of the world. So there are parts of the world where the laws are very unclear and probably will remain unclear. And then there are parts of the world where they are becoming clearer, namely in Asia and the Middle East. And I think out of those places, you will start to see some of those first transactions.
Sergey, I know we got to start to wind down here pretty soon. I guess, give folks a sense of, give us some of that sweet alpha. Like, what can folks be expecting from Chainlink next? What should we be looking forward to?
I mean, I think we've said a lot of the things that we're trying to achieve. I think Chainlink really now is a platform that's going to continue to generate more service types, whether it's about identity or different types of data, or more robust connectivity, or other types of off-chain computation that enables the on-chain contracts to do more. I think that trend of Chainlink as a platform, we're pretty much on that path. And once you get down that path, you're really on that path to make a platform. The parts of the platform, I think, will continue to interact in more and more efficient ways, so that people can build more and more advanced applications. I think the two things that people can look at is, at the end of my SmartCon presentation last year, I had final two slides at the end there where I mentioned something called the decentralized computing marketplace, where people can go with any budget and generate any Oracle networks they want very efficiently. And then also something called the Chainlink Composer, which I showed a black and white screenshot of, because that's the stage of design that thing was in. And that is like a tool where you can combine all the Oracle networks into a single kind of basically decentralized stack of solutions around a contract, around a smart contract. So those are the two things that are there. I think you'll also see more capital markets activity. I don't think that ignoring this group is a wise move for our industry, and I think everyone is realizing that. Like, it's really kind of telling to me how people went from, we have to destroy the banking system, to, wow, look at that, BlackRock just bought some Bitcoin. Man, those guys, I always liked those guys. I always thought their logo looked nice, or whatever, right? I think that very basic economic incentive will take hold very, very strongly. So I think building the transactional standards, the data standards, the connectivity rails, all of these things between these places that very naturally are going to want to transact and do want to transact, even though people can't like clear as day see it, how they're going to transact. I mean, I can clear as day see it, so it's fine. And I think our community can see it, and all the people building with us can see it. And I think that's enough to get the ecosystem to a place where it can be proven to be true. And then once it's proven that it's true, that all the TradFi institutions want to and will soon be able to interact with blockchains on the public side, I think that'll be a big deal, because the basic arithmetic of that situation is very, very, very big. It is the biggest source of all net new usage for blockchain technology. So, that's another thing I guess people can expect, or that's what we're going to work towards.
Awesome. Yeah, that's inspiring stuff. Sergey, I obviously been a big fan for a long time. I don't know, Michael or Vance, if you guys have any other questions, but you've been super generous with your time.
No, thank you for the time, Sergey. This is great.
Yeah.
It's good to get a download, especially on CCIP. It's somewhere I definitely want to focus a little bit more on. So yeah, thanks for coming on the pod. We'll be with each other soon in London in person, which I'm looking forward to. And yeah, we'll have to do it again at some point in the future.
Wonderful. Thank you very much for having me, Michael and Vance. Always a pleasure to see you. Michael, very nice to meet you here on the podcast. It's been great chatting with you. Thank you very much.
Hey everyone, Mike here. If you're a Bell Curve listener, you know that transferring assets across chains can be a massive pain. I certainly do. I complain about it on this program all the time. That is why we're incredibly excited to have teamed up with the Wormhole Foundation, the stewards of the Wormhole Protocol. And the coolest part about this particular partnership is that they have made custom Bell Curve NFTs, which you can get and mint for free. So click the link at the bottom of this episode, get your free NFT.